All right, we're moving on to example number 4 now. In this particular reaction, we're going to take a look at, let's get our pen back here. Here we go. We're going to take a look at the reaction where solid iron reacts with silver nitrate, which is in solution, AQ, to produce iron 3 nitrate, FeNO3, in parentheses 3, which will be in solution, AQ, plus silver metal. This is actually a single replacement reaction because the iron is replacing the silver in the compound. To balance this thing, we'll need to put a 3 out in front of the silver nitrate and a 3 out in front of the silver, and we are now balanced. Now here's the question. In the reaction above, what mass of iron, Fe, which is a solid, is needed to produce 100 grams of silver, Ag, which will be also in the solid phase. So again, whatever you're given, in this case we're given silver, Ag, we're going to take that 100 grams of silver that's being produced and backtrack it to the mass of the iron that's necessary. Now the first thing that you want to do using your molar roadmap is to change the silver into moles. Everything you do has to be changed into moles most of the time. Alright, so let's go ahead and do that. If you look at your periodic table, 1 mole of silver is going to have a mass of 107.87 grams. And notice again, we're making sure that we use all of the label, the grams of silver, divide out top and bottom. Next, we have to change that over to the species that we want. And in the question, it says we're looking for iron. So we've got to go from silver all the way over to iron, which of course, when there's nothing there, is assumed to be a 1. So we're going to use that mole ratio, which will be 1 mole of iron over 3 moles of silver. So the moles of silver divide out top and bottom with moles of silver. Now the question again asks us what mass of iron. So we don't want to stay in moles of iron. We want to change that into mass to go from moles to grams. So you use the molar mass. On the periodic table it says 55.85 grams of iron for every 1 mole of iron. The moles of iron divide out top and bottom. And now you're ready to do the calculation. So you have 100 times 1 divided by 107.87 times 1 divided by 3 times 55.85 divided by 1, and when you perform that calculation you should get 17.26 grams of iron, grams of Fe. Alright? So, I'm hoping that you're picking up on this. The pattern is always going to be the same when you're doing stoichiometry. Change whatever is given into moles, mole ratio it over to whatever new substance you want, and then change it back into whatever they ask for. Now, so far, everything we've done has been in grams. But you don't have to do it that way. In fact, if we scroll down and flip the page over to the next page, you can use your molar roadmap to change from a variety of substances into moles. Here's the key step. Whenever you want to do a stoichiometric calculation, you're going to have to go from moles of something over to moles of another thing. And of course, to do that, you always use a mole ratio. And the mole ratio comes from the balanced equation. Alright? But before you make that change, you have to get into moles. So if you happen to be in grams mass, you have to change that into moles using the molar mass. Once you get back into moles on the other side, you can change that back out of moles into mass, again using the molar mass. That's what we've done in the past two examples. But you don't have to do that type of a calculation. You could do everything in, say, particles. We're using 1 mole equals 6.022 times 10 to the 23rd. All right. Or when you get on the back side of that, here, let me just a second. I'm going to erase all of this, and we're going to make this just a little bit bigger. How's that? Okay, so let's try this again. We're going to go from moles over to moles. All right, and in order to go between the two, use the mole ratio from the balanced equation. All right, and if you're going to get into moles, you do need to, if you're going from mass anyway, we'll put it all the way down here, you do have to use the molar mass. And if you get into moles on the other side, you can make that conversion using the molar mass. Of course, you do not have to work in grams. You could be working in particles. Where 1 mole equals Avogadro's number, 6.022 times 10 to the 23rd, and that can also be performed on the backside of the calculation. So we have particles, and 1 mole equals 6.022 times 10 to the 23rd. Or we also showed you how you can use the volume of a gas at STP. So we have volume of gas at STP, and you use 1 mole equals 22.4 liters. And we'll also do that on the back side as well. Okay, and 1 mole equals 22.4 liters. Alright, so here's the deal with this whole thing. It doesn't matter where you start on the molar roadmap. You can start with mass, particles, or volume. If you're going to do a stoichiometric calculation, you have to change into moles, but you can do that. We did that in Chapter 10. The only new thing that we've shown you is that you have to use the mole ratio from the balanced equation to change it over to moles of a new substance. Once you're into moles of that new substance, you can change it back into grams, back into volume of a gas at STP, back into particles, whatever the question asks you to do. And in the next podcast, we'll go ahead and practice some of those calculations. We'll see you next time.